These are points, they're not vectors, they don't have chevrons, there's no mention that they're vectors, and they have that little letter P and a little letter Q. If you plot those 2 points and it asks you to make a vector PQ, then you just plot point P, 1, 2, 3, negative 1, and you go to point Q, which is negative 2, and then up 5, 2, 3, 4, 5. You put Q, and you make a vector that goes between them. And it says PQ, so that implies an order that you're going from P to Q. And the components of that then are how many X point units did you go to the left and how many Y units up. And that'd be negative 5 to the left and 6 up. The vector is described. It's an arrow with direction and magnitude, but you can always describe it in its X and Y components. And it's negative 5 because it's to the left and positive 5 up. That vector can be moved anywhere you want. And so let's see if this works. I can grab this thing. You should be able to grab that and move it around any way you want. You can have a negative 5, 6 vector any way you want as long as it has the same direction and magnitude. This one's just specific because it said it wants one between the point P and Q. Okay, so that's the low and dirty on that. And then there's some arithmetic. If you triple the vector V, you triple its components. And then if you double the vector W, then you get negative 2, 6. And then in the end, you're adding 2 vectors to each other. They're X to X and Y to Y. So that makes triple that's 9, and that's 3. Pow. And then negative 4 and 12 goes with that. And if you add their X to X, you get the final vector, which is, according to my calculations, 9 take away 4 is 5, and 3 and 12 is 15. So you can check against those, 5, 15. Hopefully that looks peach keen. Same thing with this one, negative 2v, so you got negative 2 times your v vector, and my v vector is 3, 1. And then my w vector is negative 2, 6. Always add X to X and your Y to Y, but first order of operations, you have to do this is called, it's a way of stretching your vector, whatever it is, you're doubling its magnitude. It's a scalar that we're applying to it. Negative 6 comma negative 2. Negative 2 comma 6, so that's kind of cool. Negative 6 and negative 2 make negative 8. And negative 2 and 6 are 4. You can argue if you like. Tell me if I add funny. And then to the bottom, it says, hey, component form of a vector with magnitude and direction. This is like what we did with all those vectors. I just want one vector. Can you remember? It's just magnitude cosine gives you the x. So this is like the first part. If I give you an airplane with a certain speed and direction, you do magnitude cosine, the angle, the direction angle, to get x, and then you do magnitude sine of the angle to get the y component. And then this is on the unit circle. Some of them aren't, so it depends on which problem you're looking at. So if it asks for exact, this one says calculator allowed, so you're welcome to get the decimal. If it said exact, then you'd use the unit circle. This one allows you to do both. So if you happen to pull out your calculator, and I don't have one with me, you can get that. But the cosine of 210 is negative square root of 3 over 2. So I'll put that on there for now, and then feel free to do a decimal on this one. And then sine at 210 is negative a half, so that'd be negative 25 halves. The thing to think about is draw these if you want to check your work. If I do a theta facing 210 and I go 25 for my vector, do these components that I got seem to make sense? Does it look like then I'm going to the left square root of 25, square root of 3 times 25 over 2, and does it look like I'm going negative 25 halves or negative 12 and a half? Does that seem reasonable? And you can check against it. And finally, for this page, and then I'll pause and I won't make a video of both pages at once, it'd be too long. But if I give you the x and y components of a vector, so 10, negative 5, so I got this lovely vector like that, will you please give me the direction and magnitude? And direction, the magnitude is the square root of x squared plus y squared, and the direction is inverse tangent of theta of y over x. If you started to memorize those, that's great. But careful when you square the negative, it's gonna be 25. So watch out that you're squaring the whole thing, or just drop the negative when you're doing the magnitude. Don't put the negative in there if you're calculating magnitude, because you're probably, there's a chance you might forget that you're squaring a negative. It should be positive. So that's 25 and 100, so squirt 125. And then my inverse tangent of y over x, negative 5/10 or negative 1/2. You're going to get something from your calculator, and in this case it'll be right, because if your vector's in the first or fourth quadrant, your inverse tangent will be correct. And you can go with it. And I don't have my calculator handy, so you can make that. I can write it in later and you can make the calculation. Okay, so that's round one, and I'll pause this because it gets a little bit long.